Hi. Today we are going to talk about polymerization and polymers in general. First of all, we will start with the term polymer. What does that mean? Polymer, if we look at it, we will find that it is made up of two parts. The first part, poly, means many, while mer means small unit. So if you add them together, you would find, or you can get the definition of a polymer, which is what? It is a molecule, a substance that is made up from joining together too many small units. These small units are called monomers. The general name for these small units is monomers. So if you want to get a polymer, you should add up together too many small units and add them, join them together, bond them together, and the product in this case would be called polymer. What type of polymers we have? We have two types of polymers. Either synthetic polymers or natural polymers. What's the difference between both of them? Synthetic is man-made, which means that man can make these polymers in industry, like, for example, plastics, all types of plastics, like nylon, for example. These are considered synthetic polymers because they are being produced in factories, in industry. Natural is they are formed naturally in our bodies. So no interference from man in producing or making these natural polymers. Examples for these are proteins. Example also cellulose. You have also starch. These are not the only examples. These are some examples of either synthetic or natural polymers. Now, let's go to talk about each of these two types with some more details. I will start with synthetic polymers. And also, these are being classified into two types according to what? According to type of reaction used to make the polymer in each case. We are agreed that it is synthetic, so it is man-made. It is made in industry. It is by industry you can make too many of these polymers. But what way you use to produce these polymers? It could be either by addition, or by condensation. What's the difference between both of them? In the addition reaction, you should use similar monomers. What do you mean by that? Let's take an example. Suppose that we are talking about CH2, which you all know as the simplest alkene ever. It is called ethene, or it has another name, ethylene. Now, if you bring too many of this monomer, too many molecules of this monomer, and allow them to react and join together, what will happen actually is that the double bond here would break down, which allows each carbon atom to take back its electron, because you all know that the bond is a matter of sharing two electrons between two atoms. When it is breaking down, each carbon will take its own electron that shared with the other carbon atom. This will allow the carbon atom here to bond with another carbon atom from another molecule. Suppose that I would just draw two molecules after breaking down the bonds with in each of them. Here I am using only, just to show you the idea, I am using two separate now molecules. After each molecule, in each molecule, the double bond breaks and the carbon atom here takes its electron, while this one also takes its electron. This will what? This will allow these two electrons from the two different molecules to bond together, and a bond will be created between the two carbon atoms here. This is the original one, this is the carbon. Here, the other carbon, still with one electron here, free electron. This is the bond, the new bond created that bonds the first monomer with the second one, while the second one is this one also. This electron is already bonded with this one in this new bond, and this one will still have its electron. This electron is also available to bond with the third monomer, and this one is also available to bond with the fourth monomer, and that's why the chain will increase up from both sides, forming the very long chain of a monomer that we can represent it finally by this way, which is what? C, C, H, 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 H. We can write here or put here a line, here a straight line. This line means that this monomer is also repeated in this side for thousands of times, and also it is repeated from this side also thousands of times. And instead of writing million, 500, 100 and so on, we just put like that. This is the idea. This is the way in which we draw the polymer, in which we draw the general composition of the monomer. Not this one, not this one. This one was just to show you how the bond is created between two different monomers. But in order to represent the polymer itself, the polymer would only use one monomer, but with the double bond broken down, with no double bond. Look carefully here, because the double bond is broken down and stretching from both sides with another, or bonding with another molecules. This line here means that you have a stretched chain from both sides. This is the monomer, this is the polymer, the general formula of the polymer, and we call it in this case polyethene or polyethylene. Why is that? Because if you use the first name ethene, so it would be polyethene. If you use the second name ethylene, so it would be polyethylene. Poly means many, many ethene from both sides. This is the way how we represent the formula of the polymer produced in this case. Look carefully here for the conditions that should be available for the reaction by addition here. First of all, you should use similar monomers. The second thing is, it is addition reaction. Addition reaction means that there should be double bond to break down, and so this will allow the monomer to add to another monomer from both sides. So there should be a double bond within the monomer to allow the monomer to break down its double bond and bond with other molecules from both sides, and allow the chain to increase more from both sides 1,000 times, millions sometimes, and to form finally the polymer that we are looking for. Going to the polymerization, by using condensation reaction, you would find that we have different conditions for that. If the condition here was to use similar monomers, here you should use different monomers. So monomers used here are different from each other. Monomers used here are different from each other. They are not the same. Like this case, they were all the same type. Then the second thing, which is very important, each monomer, this is very important, should have two similar functional groups at each side of it. Each at one side of the monomer. What do we mean by that? Let's see example. Let's see example. Here, I should use different monomers. One monomer is like that. This is one monomer, monomer 1. What about the other monomer? Let me give you an example for the other different monomer. Is there any molecule in the world with a box inside it like that? No. The box here represents a chain of carbon and hydrogen, which I don't care about. It doesn't interfere in the reaction. It has no role in the reaction. It has no effect in the reaction. So it just being represented by a box. Box here means that you have carbon, hydrogen, carbon, hydrogen. I don't care about the number of the carbon and hydrogen this side or this side. I don't care about. So since it has no effect on the reaction, it has no role in the reaction, we just represent it by a box like that. But look carefully what we did here. You should use two different monomers. This is, I think, an example of that. This monomer different than this one. The second thing, each monomer should have two similar functional groups, each at one side. This is functional group, which is the carboxyl group, if you remember it. C, double bond OOH, it's called carboxyl group. And the same carboxyl group at the other end. This is what I mean by each at one side. Carboxyl group here, on the other side, another similar carboxyl group. For the other monomer, hydroxyl group on one side, another hydroxyl group on the other side. This is, again, two examples for the conditions of the monomers used. What will happen now, if you remember, what type of reaction takes place between carboxylic acids and alcohols? If you don't remember, I will remind you with it, which is the esterification reaction. Esterification reaction, which forms ester, is a reaction that takes place between the carboxyl group of a carboxylic acid with the hydroxyl group from an alcohol. How is the reaction taking place? Also, we said before that we should take OH from here, H from here. And of course, we are not using only one monomer of each. Here you should use many monomers, N, and also here you should use many. N here means too many molecules of this monomer. N here means too many molecules, but I am just showing what happens between two of them. Now, what will happen here, this will lead to the product of the following polymer. Here, C double bond O, OH. This is the box here, C double bond O. Now, we took the OH, and from this side we took the H, so only O remains here, and here, while this one has the H. And instead of the single bond between two similar carbons, here the bond would be between C double bond O and the O. This one, C double bond O here, with this O, it is called, if you remember, ester link. Ester link. Okay. You said that you have too many of these monomers. How can we represent too many? Okay. Now what happens is that this OH would be facing another OH from another monomer like this one from this side, while this OH is going to be facing another C double bond O from a second monomer. Again, this monomer, we called it monomer 1. Monomer 1 from here would face the OH from monomer 2 from this side. This one, OH group, from monomer 2 would face C double bond OH from another molecule from this side. This means that in order for this drawing to be stretched and expressing the polymer, I would erase this H, meaning that we are taking this H to allow it to bond from another side. And from this side, we would take what? OH. And like we did here, we make it straight line. Straight line means that this is going to be repeated all the time from this side and from this side. And we put N here. And look carefully what is in U. Is there any other product beside the polymer when the polymer is formed? Is there any side product beside it? No. Because you will not lose anything from the composition of the monomer in this case. But in this case, you are removing what? OH with H from here. You are removing H2O water. So, beside the monomer, there is what? H2O molecules. How many molecules you would get? You would get 2n minus 1. 2n, yani suppose this is 1000, you would get 2 times 1000, 2000 minus 1, so you would get 1999 water molecules. Suppose that you have 100 molecules, you would get 200 minus 1, 199 molecule of H2O. And look carefully that for each bond within the polymer, each bond, each ester bond, here how you can locate the ester bond. Look between C double bond O and the other O. Whenever you find C double bond O and O, just between them is the ester link. Each ester link created, it would also give off one water molecule. Each bond, each ester bond would give one H2O molecule. 2 ester links would give 2 water molecules. 1000 ester link all over the polymer would give what? 1000 ester link would give 1000 water molecule. So this is how, why is it called condensation? Because there is a side product beside the polymer is formed, which is what? H2O. Here, nothing beside the polymer is formed. That's why it is called addition. Addition means adding together without losing anything. Condensation means adding together but losing some small molecules, which are what? In this case, water molecules. This is the difference between addition and condensation. Another example for the both of them. Another example here. Okay, I will give another example for the addition and another example. By the way, I'm sorry, the one that was here, it is called polyester. Why is it called polyester? Because too many ester links are being created all along the chain. So the general name for this polymer is called polyester. Why is that again? Because of the ester linkage that are formed all over the polymer. Since we have too many links of that kind, ester links, so we are calling them, or we call the polymer as a polyester. Here, suppose that I have this one, which is propene or propylene. Any of these two names is correct. Don't forget, we said that in the addition reaction we should use the same monomer with a double bond. So if I want to use N of this and polymerize them, what will happen is the same idea. I should break down this one and give each carbon its own electron. This will allow each of these two carbons to bond from both sides. So if this one want to bond with another molecule from this side, and this one is going to bond from another side, this is the problem here. This one is free to bond because nothing is in its way to bond with another molecule. While this one has CH3 part which prevent this carbon from bonding with another carbon. So how can I manage the composition of the monomer in order to draw a very good drawing for the polymer that is produced in this case? In this case, I should just do what? Take this CH3 down. Here, like this. This is the carbon. This is the CH3. Because it is the same, bonded to the same carbon. No matter where the position of the CH3, either up, down, left, right, it is the same since it is bonded with the same carbon. And this one has its hydrogen. The double bond will break down as we agreed upon about that before. Now, the CH2, you would have H here, and now you should draw this chain, and you would put N. This is how to draw the polymer in case you have more than one carbon atom. Just put on the main chain only the two carbons with the double bond. And any other carbons, just take them down. Just leave the two carbons with the double bond in the main chain and others are down. This is called what? Polypropene or polypropylene. This one used to make ropes. Polyethylene used mainly to make grocery bags that you use to put your grocery in when you are coming out from any mall, supermarket, and so on. This is used to make ropes. The other one, which is the polyethylene, used to make grocery ropes. Let me give you another example for the condensation. Here we said that we should have two different monomers, each with the same functional group at each side of the same monomer. Here I would choose what? This is monomer 1, this is monomer 2. The conditions: different monomers, each has the same functional group at two ends. What will happen here is that if you use N of this, the bond will be created between these two. And the same thing, you would expect H2O to be given off, but the idea is the type of bond here is different. In the other example, it was between C double bond O and O. Here it is between C double bond O and N. So how would we draw the polymer? It would be like that. We would put a line here to represent that this side will share with the OH. This one, C double bond O. Here with what? With NH. Here you have the box again here. Here. With what? The NH2, the amine group. Here it is called the amine group. It is sharing all the time with the hydrogen. So in this side I would remove it. Removing it means that it is lost with another monomer beside it, and you would write what? N here, again plus 2N minus 1 H2O. This is the bond. It is called amide linkage. The other one was ester linkage. Anything between, any bond between C double bond O and NH, it is called amide. Any bond between C double bond O and O, it is called ester, like the example before. It is called ester. So this one is called polyamide. Where from the name comes? Because poly means many, amide represents the bond that is created between the monomers all over the polymer. This is what I can say for the synthetic polymers. Now, let's go to the other type, which are what? The natural polymers, and we will take one important example. Which is what? Proteins. We can say that the monomer used is alpha amino acid. What is the amino acid? Amino acid is an organic compound that has the formula, the general formula like that. NH2 COOH HR. Look carefully. Amino represents NH2. Acid represents the COOH, which is the carboxylic acid functional group. So it is combining two functional groups together within the same compound. Alpha represents something that you don't need to know for sure. Just make it as a knowledge, a general knowledge, but you are not going to be asked about, which is what? Alpha is only used to represent the amino acid at which the both functional groups are bonded with the same carbon atom. If the two functional groups are bonded to the same carbon atoms, it is considered alpha. If the NH2 group and the COOH group are bonded each to different carbon atom, so it is still amino acid, but it is not alpha. For example, suppose that I have CH3, CH, NH2, CH, CH3, COOH. It is amino acid. Why? Because the conditions of the amino acid are found here. What is it? COOH, NH2, H here, and R group here, and the H, and the R group. You can say R group with two different functional groups, carboxyl group and the amino group are found, but the idea is like that. This COOH is bonded to this carbon, while this one is bonded to a different carbon. It is still amino acid, but not alpha. Not alpha. While, take this example, CH3, CH, NH2, COOH. Here, you would find that this COOH is bonded to this carbon, NH2 is bonded to the same carbon. So in this case, it is alpha amino acid. The one responsible for building proteins as polymers are the alpha amino acid. So they should be alpha amino acid. Otherwise, if it is not alpha, it would not make a protein. So what is the monomer used to make the protein? It is what? The alpha amino acid. How does these monomers bond together to form the protein? The same thing as condensation. Here, CH, N, H2, CH3, COOH. Look carefully. It is amino acid. Why is that? It contains R group, hydrogen, and the COOH is bonded to this carbon, the same carbon which bonds with what? NH2, so it is amino acid. Suppose I have it with another, for example, CH3, CH3, or CH here, C2, H5, H. Let me put it in the way that make the idea clear. Again, the same thing here. Alpha amino acid. The COOH is bonded to the same carbon with that, and it contains R group and H around it. So don't forget that the amino acid should have carbon bonded to COOH, NH2, I don't care the position, they should be carbon bonded to that, and one hydrogen and one R group. Are these found here? Yes. This is the NH2, this is the COOH, this is the H, this is the R group. This is the R group, H, COOH, NH2, and so on. And now, suppose that I have thousands of this monomer and thousands of this monomer, and they are going to bond together. What will happen is the same as condensation. You would take OH from here and here. This would give you what? This is the formula of the protein in this case. NH. I would put what? A line here to represent that this part, this side, is going to share with the H atom. And this one would be what? C. H. CH3. C double bond O, and the link that you are going to give me the name now, I think it is called what, since between C double bond O and NH? Amide linkage, yes, it is called amide, as we took it before, C2H5, and this part is going to share with which type part of it? OH. So I will draw here a line, and by repeating these two units thousands, millions of times, this is the protein. This is the protein, and the bond here is called what? Amide bond. Amide bond. So the proteins are named generally by polyamide. Polyamide is the same as we took it before, polyamide, but the difference is that the other one we took it before was synthetic polyamide. This is what? Natural polyamide. The natural polyamide is the protein. Again, the process here is not taking place only by two. You should repeat these units thousands, millions of times to get the protein. And the difference between each type of protein is what? What's the difference between difference between types of proteins? The difference is regarding to what type of R, what is the R group in each of them. Because in all cases, carbon, hydrogen, NH2, COOH are the same. The difference is with the R group. The R group, difference in the R group makes different type of proteins. You know that proteins are either found in hairs, in nails, in our muscles, in our bodies. Different types of proteins you have in your body. What makes different type of proteins? The R group. The difference in R group, the difference in R group from one monomer to another one makes different type of proteins. This is the idea of proteins and how they are. I'm sure that if you want to get the monomers, suppose that you are given this part as a question, and you are supposed to give the main monomers that make it, you only need to do one thing, which is what? Look at the location of the amide bond. Just break this down. I'm just giving you the idea. If you are given this part without the monomers, and you are being asked to give out the monomers that make it, you just go to the amide bond between the